In this lecture, we are going to go over my solution to the maximum subarray assignment assigned in the previous lecture. I hope you had a successful attempt at creating a solution for the assignment, and if you have any questions about my solution, please feel free to ask them in the Q&A section. So I went ahead and kind of set up the function that we're going to use. Obviously we need to pass in an array here, so I'm going to do mine of type I32, and then in order for us to return the maximum subarray value, we want to return an I32. So I'm going to use a temporary array to kind of store some values. That way I have a little bit of room to work with, and we want to just go ahead and assign in a value into that temporary array. That way we have at least one result, and we want to create our result array where our answer, or our result variable, which is going to be the answer that we return at the end of the function. So since we already started out at index 0, we can say for for I and 1 to the length of the array, and then if temp of I minus 1 is greater than 0, so we do not have a negative prefix here, then we want to say temp of I is equal to temp of I minus 1 and plus the next value in the array that we have passed in. Otherwise, temp of I is equal to array of I, in which case we are going to just go ahead and move our index up 1. And then for our result, we want it to be equal to the max value of our temp of I. So remember, from the longest common subsequence, max is going to compare result to temp of I, and whoever wins that comparison, whoever is greater, is now going to be assigned to the result variable, and lastly we want to return our result. So this is all we actually have to do for the maximum subarray. So let's create some test cases to make sure that it all works. So we will test it out. So let's create a test, fn test max subarray. So we will say let array is equal to a vector, and we will say 1, 0, 5, and 8. We'll go non-negative to start, and in this case, if we call max subarray and pass in our array, we expect what is 1 plus 0 plus 5 plus 8, 13, so 14. That is what we would expect to be here. So we have 1 plus 0 plus 5 plus 8. So that's a very simple test case. Let's do another one. Let's say let array 2 equals vector, and we'll do some negative values in this one. -3, -1, -8, and -2. And here we expect to see only -1 returned, because nothing greater than -1 can be added on to this. So we would expect assert equals of our max subarray of our array 2 to be -1. do another array, and we'll make this one have a couple of different mixed matches between negatives and non-negatives. So we will say, let's go -4, 3, -2, 5, and -3. So in this case, we would expect it to be -3 plus a -2 plus a 5, which equals 6. And we don't have -3, it's regular 3. Yes. Alright. So we'll do our assert equals here, max subarray on a reference to array 3, and we would anticipate 6 being returned. So these are 3 pretty good test cases. So if we run them, we see that they pass successfully. All 3 of them do. So it looks like my implementation of the max subarray is working correctly. So again, I hope you enjoyed this assignment, and I hope you enjoyed learning about the concept of dynamic programming. If you have any questions regarding dynamic programming or my solution to the max subarray, please feel free to ask them in the Q&A section, and I will see you in the next section when we start discussing the graph data structure.